Hi guys, my name is Casey David and I'm here to discuss the evaluating of determinants by the pivotal elements method. First, what is pivotal element method? The pivotal element method is one of the useful method in evaluating determinants. In the getting determinants of a matrix of order n, the pivotal elements method center is solution on finding a pivot element, which is 1 and creating an n-1 determinant from here. For the step, an example is used for better illustration. First, if the given determinant of order n has an element unit 1, use this a pivotal method. Second, cross out the row and column through the pivotal method. Third, from each element of the resulting determinant of order n-1, subtract each remaining entry by a product of the elements in the pivotal row and column that intersects with the remaining entry. Fourth, the value of the given determinant is -1 raised to I plus j times the value of the new determinant. Finding the given determinant 3 by 3 matrix of pivotal method. Example 1. 3, -2, 5, 4, 1, 2, -1, 3, 6. So, first, we must locate our pivot which is 1. So, in the mid here, in the matrix or pivot, it's located into row 2, column 2. Step 2 will be cross out the row and the column. We call it pivotal row and column. After that, upon crossing it out and locating your pivot, there will be always be -1 raised to sum of position of its roster column, which is it in our case t is -1 raised to 2 plus 2. Because our pivot is located in row 2, column 2. Then after that, we're going to subtract each remaining entry from the product of the elements. It intersect with 3. We can rewrite this. The remaining entry 5, -1, 6, then minus 4 times -2 minus 2 times -2 minus 1 minus 4 times 3, then 2 times 3. After that, we're going to subtract it one by one. T plus 1. 3 minus 4 times -2 equals 11. 5 minus 2 times 2 equals 9. -1 minus 4 times 3 equals -13. 6 minus 2 times 3 equals 0. Next. After that, we're going to do our upward and downward or diagonal. This is D equals 11 times 0 minus 9 times negative 13. Then, after this, we're going to solve it, and so our final answer will be the 117. This is the final answer. Finding the given determinant of 4x4 matrix of pivotal method. Example 2, 2, negative 5, 3, 4, 0, 3, 2, 2, 0, 0, 4, 1, 0, 0, 0, negative 5. So first is our pivot here is 1 after locating, cross out the row and column. So first, our pivot here is 1 after locating the cross out it row by column. Column 4. After that, upon crossing the pivot, we can rewrite the remaining entry. This is negative 1 raised to 4 plus 3 because our pivot is located to row 4, column 3. Next, we can write the remaining entry, which is 2, negative 5, 3, 0, 3, 2, 0, 0, 0. So we're going to subtract the remaining entry. Then D minus 1, negative 1, 2 minus negative 0 times 4, negative 5 minus 0 times 4, 3 minus 4 times 4, 0 minus 0 times 20, 2, then 3 minus 0 times 2, 2 times minus 4 times 2, 0 minus 0 times negative 5, 0 minus 0 times negative 5, 0 minus 4 times negative 5. After that, we're going to subtract it. The 2 minus 0 times 4 equals to negative 5 minus 0 times 4 equals negative 5. 3 minus 4 times 4 equals negative 13. 0 minus 0 times 2 equals 0. 3 minus 0 times 2 equals 3. 2 minus 4 times 2 equals negative 6. 0 minus 0 times negative 5 equals 0. 0 minus 0 times negative 5 equals 0. 0 minus 4 times negative 5 equals 0. Next, we're going to factor out by d equals 2, 1, negative 5, negative 13, 0, 3, negative 6, 0, 0, 20. And we're going to crossing out. Our solution will be t equals negative 2, 1 raised to 1 plus 1 is because column 1, 2, row. Then we're going to crossing it out. Our solution will be the remaining entry is 3, negative 6, 0, 20. After that, each remaining entry byproduct of the column it intersect with t negative 2 minus 1 3. Rewrite the remaining entries negative 6, 0, 20. Then minus 0 times negative 5 minus 0 times negative 13 ay 13 then minus 0 times negative 5 then 20 minus 0 times negative 13 equals negative 2 then 3 minus 0 times negative 5 equals 3 negative 6 minus 0 times 13 equals negative 6 0 minus 0 times negative 5 equals 0. 20 minus 0 times 13 equals 20. Next, we're going to do a upward and downward diagonal. D 2, negative 2, 3 times 20 minus negative 6 times 0. Then we will cancel it because negative 0 times 0 is 0. Then copy this one, negative 2 plus 3 times 20 equals 60. So our final answer will be t is to 20. That's it. And that's how we solve the determine using Fibutal. So let's proceed to the choice of method.
Chio's method is also one of the methods used to evaluate the determinant of a n times n order matrix where a11 or the first element should not be equal to 0. In this video, I will show to you on how to find the determinant of 3 times 3 matrix using Chio's method. So let's have our first given matrix where A is equal to 1, 3, and 2 on the first row, 3, 2, and 2 on the second row, 2, 3, and 1 on the third row. So here, we need to find the determinant of this 3 times 3 matrix. But the Chio's method to work with, we need the first element to be a non-zero number. That may be a negative or positive number, but other than 0. As you can see on the given matrix, the A11 or the first element is 1, and it is a 3 times 3 matrix, so Rn will be equal to 3. And the formula for the determinant A is equal to 1 over the first element raised to n minus 2, which is constant, and then we will copy the given element. In solving the determinant for A, first is we need to rewrite the formula and substitute A11 or the first element, which is 1, raised to n, which is 3, minus 2, which is a constant number. Next, we need to group each elements. So for our first group element, we will use the first column and the second column, which is 1 and 3, 3 and 2. Next, for the second group element, we will use the first column, which is 1 and 3, and the third column, which is 2 and 2. For the third group element, we will use the first and third row, which is 1 and 2, and the first and third row on the second column, which is 3 and 3. So for the last group element, we will use again the first and third row on the first column, and the first and third row on the third column. After we group the matrix, we need to solve each group elements. So to solve each group elements, we need to cross multiply the given element and subtract its product. So on the first group, we have 1 multiplied by 2 is equal to 2, and 3 multiplied by 3, which is equal to 9. Then subtract each product. 2 minus 9 is equal to negative 7. And we will do the same process in the second group and the following group. So 1 multiplied by 2 is equal to 2, minus the product of 3 times 2, which is 6. So 2 minus 6 is equal to negative 4. Next, 1 multiplied by 3 is equal to 3, and 2 multiplied by 3 is equal to 6. So 3 minus 6 is equal to negative 3. For the last group, 1 multiplied by 1 is equal to 1, and 2 multiplied by 2 is equal to 4. Then subtract each product. 1 minus 4 is equal to negative 3. Next, we need to simplify the given formula here. So 1 over 3 minus 2 is equal to 1. 1 raised to 1 is equal to 1. So it will be 1 over 1, or simply 1. After that, we will do the same process again, which is the cross multiplication to solve this element. So negative 7 multiplied by negative 3 is equal to positive 21, minus the product of negative 3 multiplied by negative 4, which is equal to positive 12. So 21 minus 12 is equal to positive 9. Then the determinant of A is equal to 1 over 1, or simply 1 and positive 9. So 9 times 1 over 1 is equal to 9. So our determinant here in this 3 times 3 matrix is positive 9. For our second example, the determinant B is equal to 0, 3, and 1 on the first row, 1, 3, and 2 on the second row, 2, 2, and 3 on the third row. In this given matrix, the first element is equal to 0, and it is a 3 times 3 matrix, so Rn is equal to 3. As I said a while ago, we need the first element to be a non-zero number so that we can use the Chio's method. So to get a non-zero number at this position, we need to interchange the column 1 with any of the columns which has a non-zero number in the top line. So we can interchange column 1 and column 2 so that our first element will not be equal to 0 and the remaining column will be the same. After transposing the first column to the second column, our first element now will be 3. So in solving the determinant for B, we will use the formula 1 over the first element raised to n minus 2, which is a constant number. Then, copy the transpose given, that is 3, 0, 1 on first row, 3, 1, 2 on second row, and 2, 2, 3 on the third row. Next, substitute the first element or A11, which is 3, and the n, which is 3 minus 2, which is a constant number. To solve the determinant for B, again, we will need to group each element so that we can do the cross multiplication and subtract its given product. For the first group element, we will use the first column and the second column, which is 3, 3, and 0, 1. For the second group element, we will use the first column, which is 3, 3, and third column, which is 1, 2. Next, for the third group element, we will use the first and third row, which is 3, 2, and the first and third row on the second column, which is 0 and 2. Lastly, for the fourth group element, we will use again the first and third row on the first column, which is 3, 2, and the first and third row on the third column, which is 1 and 3. And to get the product of each group elements, we need to cross multiply the given element and subtract each product. So here, 3 multiplied by 1 is equal to 3, minus the product of 3 times 0, which is 0. So 3 minus 0 is equal to 3. Same process as well on the following groups. So 3 multiplied by 2 is equal to 6, minus the product of 3 times 1, which is 3. So 6 minus 3 is equal to 3. Next is 3 multiplied by 2, which is equal to 6, and 2 multiplied by 0 is equal to 0. So 6 minus 0 is equal to 6. And lastly, 3 multiplied by 3 is equal to 9, and 2 multiplied by 1 is equal to 2. So 9 minus 2 is equal to 7. After that, we need to simplify the given formula here. So 1 over 3 minus 2 is equal to 1. 3 raised to 1 is equal to 3. So it will be 1 over 3. Then we will use the same process here, which is the cross multiplication to get the determinant of B. So 3 times 7 is equal to 21, minus the product of 6 times 3, which is 18. So 21 minus 18 is equal to 3. So the determinant of B is equal to 1 over 3 multiplied 3. Then simplify. 3 multiplied by 1 divide 3 is equal to 1. So the determinant of B now is equal to 1.